Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss Poynting theorem and Poynting vector. Let's begin. First of all, we have to understand what is Poynting vector. As we know, when electromagnetic wave travels in space, it carries energy and energy density, which is always associated with electric field and magnetic field. Let me understand it graphically. X, Y, Z. If electric field along y direction and magnetic field intensity along z direction, then their oscillation means the propagation of electromagnetic wave along x direction. So, E vector and H vector E vector here is the S vector and x direction, so the propagation of electromagnetic waves. Therefore, the rate of energy travel through per unit area, that is the amount of energy flowing through per unit area in the perpendicular direction to the incident energy per unit time, is called Poynting vector. That is, Poynting vector is represented by P vector is equal to E cross H vector. The cross product of E vector and S vector, which represents the Poynting vector, that is the rate of energy travel through per unit area. This is the direction of electromagnetic waves, direction of electromagnetic wave That is why the direction of Poynting vector, that is the direction of E cross H vector, this one is perpendicular to the plane containing E vector and S vector. The cross product of two vectors, the resultant of cross product of two vectors is nothing, that one is the perpendicular to the plane containing E vector and S vector. So, the direction of Poynting vector along x direction, when y direction represents the propagation of electric field, z direction relates to that of propagation of magnetic field. Therefore, the Poynting vector along that of x direction. The direction of Poynting vector is perpendicular to the plane containing E vector and S vector. Since that Poynting vector represents the rate of energy transfer per unit area, so the unit of Poynting vector, rate of energy transfer per unit area, energy transfer, that is W divided by meter square. Energy watt per meter square, that will be the unit of Poynting vector. That Poynting vector also called instantaneous flux density. Flux density, as it is referred to the energy transfer per unit area, therefore we call it as instantaneous flux density. These are some basic points towards Poynting vector. What is Poynting vector? How we represent Poynting vector graphically as well as mathematically, and its physical significance. Next, Poynting theorem. Poynting theorem. This theorem gives the expression of the law of conservation of energy in electromagnetic field. The statement of Poynting theorem states that the net power flowing out of a given volume V is equal to the time rate of decrease of stored magnetic energy in that total volume decreased by that conduction losses. Energy in that volume and decreased by that of conduction losses, means the total power leaving that volume is equal to the total power used, in the rate of decrease of stored magnetic energy minus the ohmic power dissipated due to that motion of charge. We can prove it by using Maxwell's equations. From Maxwell's equations, grad dot D is equal to rho, equation number 1, grad dot B is equal to 0, equation number 2, grad cross E is equal to minus del B by del T, equation number 3. Fourth equation, grad cross H is equal to J plus del D by del T. Now we have to multiply, or we can say that equation number 3 scalar product with H and equation number 4 scalar product with E, and subtracting. Equation 3 to be scalar product with H vector, and equation 4 to be scalar product with its opposite E vector and subtracting. We have scalar product to that of equation number 3, the H vector, H dot grad cross E minus equation number 4 with that of E vector dot grad cross H is equal to equation number 3 multiplied scalar product with H vector minus H dot del B by del T minus E vector dot j minus E vector dot del d by del t. Or look that expression, we can use the property of vector identity. The entire term can be written as grad dot E cross H is equal to minus H vector. In place of B, we can write mu into H del by del T, that is mu H minus E that J vector minus E. In place of D, we can write that is epsilon E vector, as we say here B is equal to mu H vector and D is equal to epsilon E vector. Is equal to minus mu to that of outside H vector dot del H vector del T minus E dot J epsilon E vector dot del E vector by del T minus mu. Look that of equation, that term can be written as half del by del T of H square. When we take half del by del T of H square, that one is 2s, 2 to cancel out that expression, minus E dot J. Similarly here epsilon half del by del T of E square from this and that term we write minus del by del T of half mu H square plus half epsilon E square minus E dot J. Grad dot E cross H. Now integrating both sides on that of volume V, that is enclosed by that of surface S, integrating both sides over a volume V, that enclosed by the surfaces we get integrating it over that of volume V, grad dot E cross H dV is equal to minus integration over that of V del by del T half mu H square plus half epsilon E square dV minus E delta J dV. Now, in that of left hand side of the equation, that the volume integral can be changed to the surface integral. That volume integral can change to that of surface integral E cross H ds is equal to minus V del by del T. In that of bracket term, half mu S square, that is the energy density for electric field, half epsilon E square, half mu H square is the energy density due to that of magnetic field, and half epsilon E square is the energy density due to the magnetic field. As we say, electromagnetic waves is nothing but the combination of electric field and magnetic field. The total energy of that of electromagnetic wave is the combination of energy density of that of magnetic field plus energy density of that of electric field. That is why we call it as del U electromagnetic, energy density of electromagnetic field dV minus E delta J dV. What are the steps here we have to taken? As I say, taking Gauss divergence theorem to convert volume integral to surface integral of left hand side term, and U E m, which one is equal to half mu H square plus half epsilon E square. This the energy density of electromagnetic wave, Similarly, this one is the energy density of electric field, that one, mu H square, energy density of magnetic field, epsilon E square, energy density of electric field. As electromagnetic wave is a combination of electric field and magnetic field. The energy density terms U of E m, energy density of electromagnetic wave. or surface integral E cross S vector. First we define E cross S vector, that is the Poynting vector. So, P vector ds is equal to minus volume integral del UEM del T dV minus V E dot J dV. Here E cross H is equal to P vector, that is the Poynting vector. This one is the expression of Poynting theorem. What exactly these terms signifies? P dot ds. P dot ds is the total power leaving the volume. See the total power leaving the volume, and that term del UEM by del T over that of volume dV, the rate of decrease of stored electromagnetic energy. The rate of decrease of stored electromagnetic energy. Last term shows E dot J dV, that is the power dissipated due to the motion of charge, that is the ohmic power. Ohmic power dissipated due to motion of charge. As electromagnetic wave propagates, then the motion of charge useful to dissipate that power. Therefore, the total power leaving is used in these two ways, means energy is conserved. This is the expression, as we say, for Poynting theorem. Poynting theorem statement, proof by using Maxwell's equations, and finally we derive Poynting theorem. So, here with the help of this video lecture we understand the concept of first, what is Poynting vector, its definition of Poynting vector and its physical significance. By using that Poynting vector we understood Poynting theorem, that one is the conservation of energy law in case of electromagnetic theory, statement of Poynting theorem, and we prove that statement by using Maxwell's equations. This is the mathematically shown that physical meaning of Poynting theorem. So, with this useful and informative notes, let me wind up the session. Thank you.